Hey guys, here's a brand new checkpoint and 4 new questions. So if you want to pause it right now, you can give these questions a try and then check with the solutions here when you're done. So here is question number 1. Question number 1 has a common term that factors out. So we're going to go ahead and factor out a 2x from each term. So if I factor out 2x, what I'm left with is x squared plus 5x. If I take a 2x out of 10x squared, I get 5x left. And then if I take a 2x out of negative 12x, I'm left with minus 6. So I know that I have an x term as a factor, so 0 is going to be a root, and the rest of this stuff I'll check to see if it factors. And I'm looking for two factors of 6 that have a difference of 5. So first terms, of course, have to be x and x. Last two terms, factors of 6 that have a difference of 5. That's going to be 6 and 1. So we got 6, 1, and the minus is going to go with the 1, plus is going to go with the 6. So there's my 3 factors. So now I'm going to have 3 roots here. And if x is a factor, then of course 0 is one of the roots. If x plus 6 is a factor, that means negative 6 is one of the roots. And if x minus 1 is a factor, that means positive 1 is a root. So this cubic polynomial that has 3 roots has 3 real rational roots: 0, negative 6, and 1. Question number 2, factors by grouping. So if I go ahead and group this here, and if I also group it here, then I can take a x squared out of the first term, first groups. So I'll take an x squared out. What I have left then is x plus 2. And in the second grouping, I can take a negative 16 out. So if I factor out a negative 16, I am then left with x plus 2, which means that I'm allowed to factor by grouping because these two terms match. So essentially I have one big binomial here, and with this binomial, if I get new color here, essentially here's one of my terms of the binomial, and then here's the other term of the binomial. So they each have a common factor of x minus 2. So I'm going to go ahead and take that common factor of x minus 2 out of each term. So this is how the factoring by grouping works. Take a common factor of x minus 2 out, or x plus 2, excuse me. And what I have left is, if I take an x plus 2 out of here, I have x squared left. So I have x squared. If I take a x plus 2 out of this red factor here, I have a negative 16 left. So I have x squared minus 16. So looking at this now, I know that if x plus 2 is a factor, then negative 2 is a root. And here I have a quadratic which can factor. This is the difference of two squares. So if I put this in complete factored form, I have x plus 2, and then the difference of two squares factors as x plus 4 and x minus 4. So my roots there are going to be negative 2, negative 4, and 4. And I have 3 roots, and this was a cubic polynomial, so that matches up. So number 2, factors by grouping, and you can solve it that way. Alright, here's number 3, and number 3 is a 4th degree polynomial which has 5 terms, which means we can't group it, so we're going to have to use the rational root theorem to identify some possible rational roots and then use a graphing calculator to make a good decision on which one to pick. So we did some work here with P and Q and looked at all the possible rational roots, and so all of our possibilities here are plus or minus 1, 3, and 9. So that's when the denominator is 1, and then when the denominator is 2 we have plus or minus a half, 3 halves, or 9 halves. So those are all of our options, which is 12 numbers plus or minus. So instead of just guessing and checking the whole time, we're going to go ahead and take a look at a graph. And so I just used some graphing calculator, some free online graphing calculator. And so if we take a peek at this graph here, looks definitely like we have one at -3. Also one at -1 here. Half and 3. So this looks like it has all rational roots. And so we just pick one. So we can go ahead and pick whatever one we want. I'll just pick -3. So if we do synthetic division, choosing -3 as a root, we'd have then 2, 1, -19, -9, and 9. Okay, so I'll bring the first term down. -3 times 2 is -6. Add those together, get -5. -3 times -5 is 15. -19 plus 15 is -4. Multiply -3 times -4, you get 12. Add them, 3. -3 times 3 is -9. Add those together, you get 0. Okay, so 0 means that it was in fact a root. And here are this is my remainder, my constant term, x term, x squared, x cubed. So now we're going to go ahead and run the remainder of our remainders or leftovers with another possible root. So if we go back and look at the graph, another possibility would be -1. So we'll go back and we'll do the same thing we just did with -1 using synthetic division. So we put -1 in the box, and now our leftovers were 2, -5, -4, 3, and then of course 0 isn't part of it. So we're going to run synthetic division, and we're going to divide 2x cubed minus 5x squared minus 4x plus 3. We're going to divide that by x plus 1. So bring the 2 down. -1 times 2 is -2. Add them, get -7. -1 times -7 is 7. Add those two together, you get 3. -1 times 3 is -3. And this is good news because our remainder is 0 again. So once our remainder is 0, we know that that was in fact a root. So here we have, this is my constant term, my x term, and my x squared. So I'm getting down to a quadratic, and this is when we can stop doing synthetic division and we can go ahead and see if it factors, or we can use a quadratic formula if it doesn't factor. So right now I have x plus 3 as a factor coming from here, and I also have x plus 1. And then I have the leftover quadratic, x squared, 2x squared minus 7x plus 3. And so this leftover quadratic part should be factorable, because if we look at the graph again, it looks like we have a half left and 3 left as possible rational roots. So that's going to be factorable, and so let's go ahead and factor that. And the first term is going to be 2x and x, and then of course 3 only has factors of 3 and 1, and I want to put the 3 here so that it groups with the 2, and I want to put the 1 here so that it groups with the x, and they're both going to be minus. So my outside product is negative 6x, my inside product is negative 1x, and so negative x and negative 6x together make negative 7x, so this is factorable. So there is 4 rational roots for this problem, and if we go ahead and list them, one of them is, I don't really like that color, let's get another color. One of them is negative 3, the other one is negative 1, and then we have opposite of 1, negative 1 is 1, over 2 is a half, so this is a half, and then the opposite of negative 3 of course is 3. So this had 4 rational roots, and of course it was a 4th degree polynomial, so we're good to go there. Last problem here, number 4, is a a sum of cubes, and it isn't right off the bat because we got to factor out a 2. So if you factor out a 2, you'll see that we have the sum of cubes. So take a 2 out of both of these, and I'm left with x cubed plus 8. Okay, so the difference and sum of cubes would be a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. And in this case, if I'm looking at, here is my sum of cubes, my a is going to be the cubed root of x cubed, so my a is going to be x, and my b is going to be 2. So when I go through and fire off the sum of cubes here, my a, every time I see an a, I'm going to put an x. Every time I see a b, I'm going to put a 2. So this is going to be x plus 2 times x squared minus 2x plus 4. So now one of my roots is negative 2, and if I can factor this, which I can't, I'll have to use the quadratic formula to find the other 2. So the quadratic formula, the opposite of b, which is the opposite of 2, so it's positive 2, opposite of negative 2, so positive 2 plus or minus square root of negative 2 squared, which is 4, minus 4 times 1 times 4 all over 2 times 1. Okay, well then this is going to be, I'm going to move over to the left a little bit here. So 2 plus or minus 4 minus 16 is negative 12, so that's going to be square root of negative 12 all over 2. Okay, split those two apart. I have 2 over 2 plus or minus root 12, that's going to be the square root of negative 4, which is 2i, and then root 2 all over 2. So I can reduce this. 2 over 2 is 1 plus or minus 2i root 2 over 2. The 2's cancel, so I just have I root 2. So there are my other 2 roots to go along with my one rational root, negative 2. So there are my 3 roots, and that concludes the checkpoint. So hopefully this helps, and we'll see you in class.